Hello, this is the 7th video on electromagnetism for classes 6 to 10. Can be used by students of class 10 to review and to understand. In this video, we will look at a few simple instruments which are used in the study of static electricity. So we have seen in the previous video that when an object is charged with static electricity, it attracts light materials like bits of paper, loose threads, and styrofoam beads. Now we use this behavior to make a simple instrument called the pithball electroscope. Okay. So historically, this was a important and useful instrument. Spith is the spongy part of a dry stalk of any crop plant. So inside a dried up maize stalk, you can find a white material which is the pith. So we are not going to use that. We are going to use a small ball of styrofoam. It's also called as thermocol colloquially, and it's a very common packing material. So we pass a thread through that bead and make it into suspended from a support, and it becomes a pithball electroscope. So this electroscope, this bead, it moves, it deflects, it moves, and it shows that object which is brought close to it is charged. So this is a styrofoam bead threaded and suspended. That's the electroscope. And I have a metal spoon which has not been charged, and it does not affect the electroscope because it is not a charged object. So this wooden spatula also does not affect the electroscope because it is not charged. Now this is an ebonite rod. I am wiping it to remove any stray electrical charges. It's not charged and it does not affect the electroscope. Next, I have a glass measuring jar. It is not charged. It does not deflect the electroscope. So now I charge the ebonite rod. By rubbing it with a woolen cloth. You can hear a crackling sound. So, okay, so the rod is charged. It's picking up the pieces of paper. And this is how it deflects the electroscope. So the electroscope moves and clearly shows that the object is charged. Now I charge the glass measuring jar by rubbing it with silk. Now it got charged. So this is a borosilicate glass jar. This material is easier to charge than ordinary soda lime glass. And you need a dry day to do these experiments with static charge. So you can see the electroscope deflects and clearly shows that the glass object is charged. So the pithball electroscope deflects and it shows the presence of charge on any object. So both the glass jar, when rubbed with silk, and the ebonite rod rubbed with wool, they cause the electroscope to deflect. You can try with straw, PVC, and other materials. So what is this ebonite? Used in ebonite rod. Ebonite is a form of rubber. It's just a hard form of rubber, just like the material used in car tires. So this ebonite, bakelite, these were all materials made of rubber, and they, at one time before plastics were used, these were very commonly used materials. We can use PVC also more conveniently because it's more easily available. Okay, so the pithball electroscope detects the presence of a charge on any object. This is a simple instrument, but it's very important instrument. Now that we have an instrument of this kind, which detects charge, let us find out a few more things about electric charge. So, in order to see how charged objects behave with each other, we are going to start with this plastic straw, charging it by rubbing it with a woolen cloth. You can use acrylic also. So we can see that it is charged. So we can see that the charged straw and the wool that was used for charging it, they're attracted towards each other. See, the straw moves towards the woolen cloth, which was used to charge it. So I need, in order to see that movement clearly, in order to have large amount of movement, you need a smooth point of contact and a small point of contact. That is why I have used that convex surface to balance it. Okay, so the straw is moving towards the woolen cloth. It's getting attracted towards it. Now I charge two plastic straws and see what happens between them. You can hear a crackling sound when you charge all these objects, but because of some noise in the background, I'm not able to play the sound of this video. So these are two plastic straws, they're pushing, so they're running away from each other. You see, you can make it move in, you can stop it and make it move in the opposite direction. So these plastic straws, charged plastic straws, repel each other. So here I have an uncharged ebonite rod, another uncharged ebonite rod. There is no interaction between them. They ignore each other. Most objects ignore each other. So, but when I charge them, they behave differently. Now it has got charged. So I balance this charged ebonite rod on a convex glass surface. It's a lens, in fact. So I need a smooth point of contact to balance it and a small point of contact. So I need a bulging uh, convex glass surface. So you can see the glass rods are pushing, the ebonite rods are pushing each other away. They repel. So now the first rod has lost the charge. So when you charge any object, the charge on it does not stay there for a very long time, particularly if it's a humid day, it hardly stays. So you need a dry day, and even on a dry day, it still leaks away into the air. So you can see they're clearly pushing each other away. So next I check what happens between a charged ebonite rod and a charged glass jar, a glass rod that is. So here you can hear the crackling sound of the object getting charged. As before, I have balanced it on the convex glass surface. So here it's a force of attraction. The glass jar is pulling the ebonite rod towards it. Look, from a distance, you can it's pulling it towards itself. So this is a force of attraction. So it's a small force, but in order to see the movement clearly, we need that smooth surface. The ebonite rod was balanced on a smooth glass surface so that the movement is enough for us to see. So now let's see what happens between two glass objects which are charged. I use a borosilicate glass test tube. It's convenient. It has a large surface which can be rubbed easily. So I rub it with silk and it's getting charged. Because glass will roll off, I've used a slightly flatter convex mirror. It's still a glass surface, but it's a little flatter than the that lens I used earlier. So this is the measuring jar. It got charged. So it's pushing away. It's pushing the test tube away. So one charged glass object is pushing the other charged glass object away. It's a force of repulsion. We can also see this repulsion between glass objects by suspending them. It shows the repulsion very clearly in an exaggerated way. So I've used a rubber band to suspend that test tube which has been charged. So you can make it come to a stop and change the direction of its rotation because of the force of repulsion. So the suspended arrangement is interesting. It was used by Coulomb. When we discuss Coulomb's law, we will come back and see uh, this repulsion between suspended charge, which is an arrangement which is similar to this. So we used a pithball electroscope first of all to verify that an object is charged. So between different kinds of charged objects, we saw different interactions. It was either attraction or repulsion. So the plastic straw, when it was rubbed with the woolen cloth, the straw and the woolen cloth, they attracted each other. The two plastic straws, which were both charged with woolen cloth, they repelled each other. They pushed each other away. The two ebonite rods, when charged with wool, they also repelled each other. Whereas a glass rod charged with silk and an ebonite rod charged with fur, they attracted each other. Two glass rods charged with silk also repelled each other. They pushed each other away. So we saw that attraction or repulsion happens only after charging by rubbing. Okay, and we use the pith ball to make sure that the object was charged. Okay. So we have seen that similarly charged objects repel each other and differently charged objects attract each other. So what do we mean by similarly charged? So in this case, we concluded that both of these ebonite rods, both of them were charged with wool, so they are similarly charged. And they repel each other. Whereas oppositely charged glass with silk and ebonite with wool, these objects attracted each other. So, using this observation, scientists concluded that there are two kinds of charges. So, they thought of them as opposites of each other and they called them positive charge and negative charge. So, a glass rod rubbed with silk was designated arbitrarily as a positive charge. And the ebonite rod rubbed with wool, PVC rod rubbed with paper or wool, and plastic straw rubbed with wool, all of these are negative charges. Okay, so using attraction and repulsion, we can sort out the various materials, whether they get positively charged or negatively charged. Once we designate that glass rod becomes positively charged. Okay, so with a little bit of experimentation, we have discovered that electricity is of two kinds. Static electricity is of two kinds. Uh, we have positive charges and negative charges, and like charges repel each other. They push each other away. Unlike dissimilar charges, positive and negative charge, they attract each other. And we also saw that rubbing produces opposite charges in the object which is being rubbed and the material which is being used to rub. So the plastic straw got one kind of charge, and the wool which was used to rub the plastic straw, it got the opposite charge. That is why there was attraction between the plastic straw and the wool which was used to rub it. We stop here for this video.